Will software engineering go off the cliff due to AI optimism? Executive summary: AI coding tools now handle 70 to 80% of routine tasks and generate up to 41% of code. But their success creates a hidden risk: the erosion of human expertise. Junior developers traditionally learn by solving the very problems AI now automates. Yet without this training ground, the next generation of senior engineers will not emerge. Software complexity grows exponentially, and the hardest 20% of tasks, mission-critical systems, novel architectures, and crisis debugging, remain beyond AI. If companies stop hiring juniors, they risk a long-term talent drought, weakening competitiveness, national security, and innovation. The cliff is avoidable, but only with foresight. Article: The Rise of AI Coding Assistants, GitHub Copilot, ChatGPT, and dozens of others has transformed software engineering at an astonishing pace. In only a few years, AI systems have gone from autocomplete tools to engines that can draft whole modules, fix bugs, and configure complex packages. Optimists herald this shift as the dawn of effortless software creation. Skeptics worry it will hollow out the profession. The truth is more nuanced. AI is powerful, but its limits, coupled with human overconfidence, may produce a dangerous skills gap in the next decade. If companies stop hiring junior developers today, where will the next generation of senior engineers come from tomorrow? The path from "Hello World" to mastery. Every programmer starts with the same small ritual: printing "Hello World." That first line of code is deceptively simple. From there, learning progresses through increasingly difficult exercises: loops, conditionals, data structures, APIs, distributed systems, and eventually gnarly problems that push one's mental boundaries. This progression is not optional. It is the crucible through which deep expertise is forged. If organizations rely too heavily on AI to handle beginner and intermediate tasks, aspiring coders may never gain the incremental experience needed to handle the hard problems. Mastery in software engineering is not downloaded overnight. It is earned through years of failure, debugging, and design trade-offs. Without that journey, who will be left to solve the problems that AI cannot? Current AI effectiveness: strong but shallow. Benchmark studies provide useful perspective. Reports suggest that AI assistants can handle 70 to 80% of routine tasks, such as boilerplate code, autocomplete, and converting natural language requests into functions. Contribute to 41% of code bases in some form, though this often includes small suggestions rather than full features. Complete 20-minute tasks like bug fixing or package configuration with about 80% success. Generate as much as 25% of enterprise code at companies like Google. This is impressive, but it also reveals the ceiling. AI thrives at repetitive, well-defined work, but falters on ambiguous, novel, or highly complex problems. Even if 80% of routine tasks can be automated, the remaining 20% is often the hardest and most consequential. That is where human expertise remains irreplaceable. The junior engineer dilemma. Traditionally, junior developers cut their teeth on exactly the kinds of routine tasks now delegated to AI. They fix minor bugs, write boilerplate, maintain legacy code, and gradually build the intuition required for complex projects. If those on-ramps vanish, so does the pipeline of future experts. Imagine a world where, in 2035, companies need seasoned architects to oversee AI-driven systems, but cannot find them. Why? Because no one was hired in 2025 to start the long climb. In short, AI may save labor today but starve the profession tomorrow. This experience drought could take decades to repair. Offshoring, national security, and trust. The U.S. software labor market has already been distorted by decades of offshoring. Many companies outsourced routine work overseas. leaving fewer entry-level opportunities domestically. Now, AI threatens to eliminate those remaining rungs entirely. This has implications beyond economics. Software is national infrastructure. Recent controversies, such as Microsoft employing Chinese engineers on defense contracts, highlight the risks when sensitive systems are built without secure, trusted pipelines of local talent. Even seemingly mundane missteps, like a toxic Windows update, raise questions. Was this code reviewed by experienced professionals or pushed through by less supervised processes? As the world becomes more multipolar, nations that fail to cultivate strong domestic engineering talent may find themselves vulnerable not only in commerce, but in defense. Complexity does not scale linearly. One overlooked factor is the nonlinear growth of software complexity. Writing code for a simple app and writing code for a rocket guidance system differ not just in scale, but in nature. The effort does not increase in a straight line. It grows exponentially as systems interact in unpredictable ways. AI's ability to handle 20-minute tasks does not extrapolate to solving challenges that stretch into years of design, testing, and maintenance. If humans are absent from the early stages, we risk having no one capable of taming the exponential complexity of the hardest problems. The mirage of 80%. An 80% success rate may sound impressive, but in mission-critical systems, it is catastrophic. Airplanes, medical devices, and financial systems cannot tolerate 20% failure. Even in consumer products, repeated small errors accumulate into reputational damage and user distrust. This creates a paradox. AI handles the easy majority, leaving humans to deal almost exclusively with the difficult minority. But if fewer humans are trained to handle those edge cases, the bottleneck intensifies. The hardest jobs remain while the supply of qualified humans shrinks. The result could be slower progress, not faster. Economic incentives and short-termism. Why might companies take the risky path of not hiring juniors? The answer is economic. Executives see AI reducing costs in the short term. Training junior developers is expensive, and their initial productivity is low. By contrast, AI tools appear cheap, immediate, and endlessly scalable. But this is a classic case of short-term gain, long-term pain. The invisible cost is the erosion of institutional knowledge. Without fresh cohorts learning the craft, the senior engineers of 2040 may simply not exist. It mirrors the way manufacturing hollowed out in the U.S. Once factories closed, the skilled workforce dissipated, and rebuilding capacity decades later proved nearly impossible. Global competition and value creation. In a multipolar world, nations compete not just on raw materials or cheap labor, but on the ability to add value to inputs. Software is the ultimate value multiplier. It turns silicon and electricity into smartphones, rockets, and financial networks. If a nation undermines its software talent pipeline, it jeopardizes its global competitiveness. Countries that continue to train engineers, whether in India, China, or elsewhere, will reap the long-term rewards. Those that abandon training may find themselves dependent on foreign expertise or brittle AI systems that cannot handle crises. Possible paths forward. The bleak scenario is not inevitable. Several strategies could preserve the talent pipeline. 1. Reframing junior roles. Instead of eliminating entry-level positions, companies could redesign them to emphasize oversight of AI output. Juniors could review, test, and refine AI-generated code, gaining exposure while ensuring quality. 2. Government incentives. Just as governments subsidize STEM education, they might create incentives for companies to maintain apprenticeship programs in software engineering, recognizing its national security importance. 3. Hybrid training models. Universities and boot camps could integrate AI directly into curricula, teaching students how to collaborate with these systems while still mastering fundamentals. 4. Cultural change. Companies must acknowledge that human expertise is not a disposable input, but the foundation of innovation. Treating coders as interchangeable parts risks undermining the entire industry. Conclusion: the cliff ahead. Software engineering faces a paradox. AI promises to automate much of the work, yet its very success threatens to erode the human expertise that underpins the field. Without a steady flow of junior engineers, the profession risks a hollow core. No one to grow into the masters who can handle the tasks AI cannot. The cliff is not here yet, but the edge is visible. 10 years of neglect could bring us to a point where we lack the talent to compete globally, maintain national security, or simply keep the digital infrastructure running. The challenge, then, is not to resist AI, but to integrate it wisely, leveraging its strengths while preserving the human pathways of growth. In the end, the future of software engineering may depend less on what AI can do than on whether we still choose to train the people who can do what AI cannot.